This is the fourth video in a series of 4, and it's about the construction of our portable camping solar generator. Okay, some warnings. This is not an instructional video. It's a demonstration of what I did. It's an experimental device. It's not approved by any agency. High current in the device can cause burns, start fires, ruin, create disruptive magnetic fields, computers, watches, compasses. If you use this information, use it at your own risk. Okay, so we got that out of the way. Construction styles. There's different types of construction styles. The first one is what I call a bag of parts, and it uses wires and keyed plugs and so on. You can buy these on the internet now. It's solar panels, output plugs, and so on. And yeah, you literally kind of construct it on site. You plug it together. It's a little bit like Legos. The pro is it's cheap, it's fast, and it's flexible. And the con is it's difficult to grab and go. You have exposed wiring, which is a safety issue. You can, have sparks, fire, whatever.
This is what I refer to as a bag of parts. This is a very old unit, and some people are still building them like this today, but frankly there's no excuse. There's too many things that can go wrong. It's very hard to pick this up and carry it somewhere because you have separate components. You take it out, you have to wire it up in the field, and it's easy to get these wrong. Even though they're color coded, if you put them on here wrong, it causes damage. It's, the output the same. You plug the output in, it's easy to get them in the wrong order, especially when you're under stress or it's dark or some such.
The next style is the almost all-in-one. So everything except the battery is in a box, and the battery is either separate, it just is a separate piece with some wires running to it, or it's in a cage underneath the box is typically the way it's done. The pro is it's easier to change the battery. The size and shape you can change without having to worry about it fitting into the box, what have you. Just about any battery will work. And it also allows gases to vent, so if you're using a type of battery that vents hydrogen or other gas, it'll allow it to get out without becoming an explosive risk. The con is it's more work, it exposes the battery to users. It's just not as clean. It's a little bit harder to grab and go. The last one is the all-in-one, which is what I now favor. It's all of everything is inside of the box. The wires, the wiring, the fuses, the battery, everything is inside of a carry box. The external components are only the devices you want to power and the solar panels. The pro is it's easy to grab and go. You can pick it up with 2 hands, put solar panels in one hand and the box in the other hand, and it'll go. It's easy to set up and operate. There's typically only one thing to plug in. The con is it is more work to build, and there's slightly more cost to putting it all together. So I've made all of these, and I prefer the all-in-one. I typically go out and buy a battery, and the controller, the plugs, the switches, all that stuff, and then I figure out how big a box I'm going to need to fit all this stuff in it nicely. If the battery fits in the box by at least one dimension snugly, so for example the depth or what have you, it makes mounting it a whole lot easier.
So what I mean by that is, in this box, the battery fits perfectly from here to the back, and I don't have to try to constrain it in 3 dimensions. I only have to constrain it this way and this way, but not front to back, so that makes mounting the battery a lot easier.
I've bought these boxes from electric supply stores. They're cheap, but they're not beautiful. They're these gray utility looking things. And the last ones I bought at an emergency lighting supplier, and they were for emergency lights, these things you see in hallways that pop on when the power goes off. And those are really convenient because it takes a lot less work. The thing's already set up to have a battery in it, usually the kind of battery you want, and it's already set up to handle electrical wiring and all that other stuff. All you have to do is reconfigure the insides of it for what you want. It costs more, and it's hard to find because it's really hard to convince the company that you want to buy just one box. They usually want to sell you the whole parts, all the parts and everything working together. But in the end, it takes a lot less work to put the thing together.
These are a couple solar generators I've made in the past. This one's a real antique. This is the latest version I've made. This is the one I talked to you about. I got the box from a company that makes emergency lighting, those lights that come on when the power goes off. You see them in the hallways of buildings. I'm going to show you the insides of this one just because it's much easier to do. Everything on this one is packed back into the corner. Can't get the camera and the lighting back in there, so but I will tell you the differences. For one, this has a better plug. This has a much easier plug to cut. As you can see, this solar panel plug here did not get it cut well and had to kind of patch it. I'm still learning. This switch up here is no good, I've found. They arc badly. They don't carry the load very well. So yeah, the old style switch like I used here was much better. This has a standard controller like we talked about. Has the on-off switch for the power output. And this box has a separate compartment for the battery, which is, you know, really that's a necessary safety feature. The battery in this compartment is cut off from all the electronics above it. So, okay, let's take a tour of this little one. On the outside, this is a box I purchased. It's an electric junction box. I purchased it from an electric supply store. The nice thing about this one is the battery fits in here really well. So I do not have to clamp it this direction. I only have to clamp it up and down and forward and backward. So that makes life a lot easier. Okay, so electric box, got some rubber feet on it. The handle is from an old camera bag. This is the battery cutoff switch, which I will talk about a little bit more later. And some vent holes for the battery. This one again does not have a separate compartment for the battery, which, you know, should happen. But anyway, again, an old model. Okay, so let's look at the front part of it. This is a standard controller, nothing fancy about it. This is a fuse that's connected to the power outputs. This is the user fuse, I call it, and then this is the solar input plug. Okay, so first set of wires, these gray wires, pretty much just run from the controller right over to this plug. Not much to that. Second set of wires are the battery wires, and they pretty much run from here through this switch and a fuse into the battery. And then the third set of wires runs from the controller through this fuse, through this user fuse in the front, to these two plugs here. So the wiring is rather simple. When you see it, it looks a little bit intimidating at first, but there's really not much to it. Okay, this is the inside. Get things here so you can see them a little better. This gray wire, again, was this set of gray wires. It just comes right over here to this plug. It should have a fuse in it. It does not have a fuse in it, but it should. The newer one has a fuse in it. The second set of wires is, one of them's the black wire, goes to the battery. The other is the red wire, comes up here, goes through the switch, through a fuse, and then to the positive connection of the battery. Again, as I said, the new switches I use are double pole so that I cut off both the solar panel and the battery at the same time. Okay, so the last pair of wires is the power plugs here. Passes through the fuse. It's harder to see, stuff's in the way, but it passes through the fuse, comes over here to the center of the power plugs, and then the negative wire comes over and touches the jackets of the power plugs here. So that's that. The hardest part about this is mounting the battery in there firmly so that it will not move. You got to kind of drop test it, make sure it's not going to move. You don't want the battery coming down there causing shorts. So what I've done is I put a piece of angle iron up in here. It's a piece of shelf material, and another one I bolted down here to the bottom. Now this one's pop riveted because I don't need to remove it, and this one's bolted in here so I can remove the battery. And then I've got a piece, I got some zip ties in there to hold it in place. And this one has been dropped, so it's been tested in real life, and it does. The battery stays in place. And the last little bit is the solar panel. Just wire the plug on there, wire the male plug on there, and put a little shrink wrap on there to keep it from splitting. Put a little convenient Velcro tab on there, and on the back side just wire it in. Nothing special to it. I use a bigger wire than I have to. This wire will handle about 10 amps, and the panel only puts out about 2 1/4. So anyway, that's it for that piece.
Here is the parts list, and the battery, we sized that already. The controller, we've sized that one. We're going to need at least a couple cigarette lighter plugs. These are the females. You don't want the low quality ones. Let me turn on the light. Like that. You want a good quality one. I don't prefer the type that are metal. I prefer to have the type that are like a high quality marine plastic, but these do work. You'll need the solar panel plugs. So that's coming from the solar to the inbox. I use female, and I use an Amphenol 4x2.5 millimeter. You're going to need solar panel plugs. So these are on the panels, they're male, and I've used my own in the past. I've cut off the ones that came with it and used my own. You're going to need a main switch to shut off the battery and the solar panels together, as we saw on the earlier diagram. And it has to be high amps, so it'll have to handle the amperage that we've specified. We're going to need 3 fuse holders in line, so we're going to need one for the panel, one for the battery, and one for the output. We're going to need 1 fuse holder, a panel type, and that's going to be for the output. We're going to need 2 battery connectors, spade or screw, so this is how we connect the wires to the battery. We're going to need shrink wrap, grommets, wire, so the wire that will work for our amperage that we need. You're going to need miscellaneous rivets, screws, tape, zip ties, that kind of stuff. We're going to need our box that we talked about, so the box has to be able to fit the battery, the control, and all that. A handle. My latest ones, I use suitcase handles, those work really well. And then we're going to need a battery hold down. So that one, you're probably going to have to make it yourself.
These are the different parts, and the first one is the battery, which we sized earlier. Going to need something like a battery clamp to hold it in place. This one was designed for another system, but something like that. This is the hardest part to make. It's something that we're going to hold the battery inside the box well. Controller. I like this particular style right here. This is waterproof. So this is my current favorite. Cigarette lighter plugs. This can be purchased almost anywhere. They make a marine style, which is very good. I don't have access to that, so I use this. The solar panel plugs, this is an Amphenol type of plug, readily available, not very expensive. The 2.5 millimeter pins are better than the 2.0 millimeter pins, so note on that. This is the female that goes in the box, and this is the male that will go on to the solar panels. After that comes the main switch, which is something like this, should be high amperage. This is a dual pole. One side will be the solar panel, the other side will be the battery. Then we have fuse holders, so you can either use this style of fuse holder or the spade type. Note on this, I take these apart and I solder the connections on the inside. So I solder these to make sure that they're up to snuff, and I also make sure that some of these, the wire leads that you buy, are way too small. So make sure you get the right size on that one. The fuse holder for the panel, which you saw earlier, so this style. Again, make sure it's the right amperage. You need things like battery connectors, these little spades. I solder these in place. This is a crimp type, but once it's crimped, I solder it. You need things like shrink wrap, which is very nice to help cover up any electrical exposed items, any copper, bare copper, anything like that in connections. You need grommets, you need stuff like wire. The wire I use is a 20 amp capable wire, even though my systems are geared mostly for 10 amp total output. What's next on the list? Miscellaneous, you need pop rivets, screws, tape, zip ties, stuff like that, rubber feet. You need a box. This box is from a project where I was going to stack multiple batteries inside here. The bottom part was going to be batteries, and put a barrier across there. And yeah, so you want that box to fit the battery controller, everything. Make sure that you can place everything in here. There's space. The next thing is the suitcase handle. I bought this from a company that repairs suitcases. And the last thing, battery hold down, which I showed you earlier. You're going to have to make something like this yourself. But it's got to be tough. It's got to be easy to get in and out. And
the final part we need, and I haven't talked about it very much, is the solar panel. We sized it. I've used this style in the past. This produces about 1 amp, and this produces about 2 1/4 amps. So this is about twice this, and as you can see, the size difference isn't that much. So this is what I go with now. This has a hard aluminum frame. This is for a sailboat, and so it's very flexible. This was $200, and this was $20, $30, and that's a long time ago, so they've come down a lot in price. So those are your choices for solar panels. So that's kind of our final item on our parts list. Some construction notes. I always solder all the connections, and I tin all of the wire leads, because there can be up to 22 junctions between the thing you're trying to power and the solar panel. And if every junction is just 1 ohm more than it needs to be, you can waste a lot of power. We're going to need big wires for lower resistance, because when wires heat up, they waste your power. So smaller wires will heat up more. You get less wasted power with bigger wires. Battery should be its own vent compartment. A lot of batteries will claim that they don't release gas, but that's only when the battery is operating normally. When the battery is malfunctioning, it can release gas. That gas can be explosive. It's usually hydrogen gas. Everything should be fused. The panel, the battery, the outputs, accessories, everything should be fused. High current will probably not shock you, but it certainly can burn and start a fire, which is not good, especially in a camping situation. Mobile systems require a main switch to turn the battery off, so when you put this thing away in the closet between camping trips or uses, you want to be able to shut the battery off, because the controller uses a tiny amount of power and it will drain the battery down. So you don't want it to go dead in storage. And the other weird thing I found out is most controllers will not recharge a battery if the battery is below 6 volts. So if you have a 12-volt battery and it's been drawn down to, say, 5.5 volts, and you think you're going to put it out in the sunlight and charge it up and it'll be ready to go, it won't, because the controller won't actuate, and the solar panel, because the controller is not operating, the solar panel will not charge the battery. Okay, page 2 on construction notes. Most small controllers are positive ground or positive common, however you want to say it. Yeah, so you have to be careful of that. You cannot run the negatives together like on your automobile. You can't tie all the negatives together. You'll cause really bad problems. I had to learn this one the hard way. Careless wiring can lead to a short if you use it near a minus ground vehicle or other. So again, be careful what you're doing. Know what you're doing, or don't do this. You cannot share the negatives, and this is what I did. This is a mistake I made. Things didn't work right, and finally I actually called the company and talked to them in person. They said, "Oh no, you can't do that. The negative is not a common." I said, "Oh, okay." I prefer to have everything isolated. So in other words, I don't want to use the case as part of the circuit. These metal cigarette lighter plugs turn the case into the ground, into the negative, and as we said, that can be kind of an issue. So I prefer to have the outputs to be isolated from the box, and everything else should be isolated from the box. You can use a heavy-duty plastic box instead of a metal one. That might be also a good idea. Here are the controller connections. We've covered this in some of the other videos, but we'll go over it again. Most of the smaller controllers, again, are positive common, so you cannot share the minus wires. We just said this. So here's the solar panel. The negative wire goes into the negative of the solar input on the controller. Here's our fuse and our switch. Notice this switch shows a mechanical connection to the switch for the battery cutoff. That's because I found that if you shut off one or the other independently, it can do really weird stuff. The controller can do really weird stuff, like send out a high voltage spike. So you want to shut these off both together. Okay, so back to the solar panel. We go through our fuse, the switch, and into the plus. Battery, we have the plus, fuse, switch, again mechanically connected to the positive on the battery, and then the negative for the battery. And then the output, we have, from the positive, we have our fuse, switch. Switch may not be necessary if you have a switch here, but I prefer to have a switch on each appliance. And then to our load, and then again the negative. So those are the controller connections. Okay, let's go look at the real stuff.
So here's the result, all pieced together. Got the solar panel out there, got a light operating, got everything plugged in the way it should be. Everything's going fine. So anyway, that's it. That's the result. I hope you found it interesting.